Hey students, today's lesson is on solving multi-step equations. So to start with, let's go ahead and talk about the key idea. To solve multi-step equations, we're going to use inverse operations to isolate the variable. So inverse meaning if we see addition, we probably are going to use subtraction, or vice versa. If we see subtraction, we'd use addition. The inverse of multiplication is division. So we're going to be kind of looking for those inverses with the idea is that we want to isolate the variable or get the variable all by itself. So, what's going on here? Here we go. All right, so example 1, solving a two-step equation. We have the height in feet of a tree after X years is 1.5x plus 15. Let's kind of think about what that means. That must mean that even if x is 0, that the height is 15. So like right now, the height is 15 feet, and every year that the tree grows, it's going to increase by 1.5 feet. So we're going to use this equation, 1.5x plus 15. I'm sorry, I said equation. I should have said expression because there is no equal sign there. So we're going to use this expression. And then we're going to set it equal to 24. So now we have an equation. 1.5x plus 15 equals 24. So our idea is we want to get the x all by itself. We're going to use the inverses. So here we see this plus 15. We're going to subtract 15 from both sides. And it's really important that I see this step. I don't want to have that in your head. I want to see you write that down. I have 15 minus 15 is 0, so I'm left with 1.5x equals 24 minus 15 is 9. Okay, so now I'm going to divide by 1.5. And 1.5x divided by 1.5 is just x. So x equals 9 divided by 1.5. See, how many times does 1.5 go into 9? 1.5 times 2 is 3, and then 3, 6, 9, so that should be 6 times. So 9 divided by 1.5 is 6. So after 6 years, that tree is going to be 24 feet tall. Does it make sense? Let's kind of do a little bit of a check and say, I'm going to use a different color. So 1.5 times 6 plus 15. We're going to see if that's equal to 24. 1.5 times 6 is 9. 9 plus 15 is 24. 24 is equal to 24. So we did it. All right, example 2 is combining like terms to solve an equation. So this time we have these x terms, 8x and 6x, and we have 25 and negative 35. So before we start solving the equation, let's combine the terms that are similar to each other, that are on the same side of the equation. So I can subtract 8x minus 6x, and I'd be left with 2x minus 25 equals negative 35. Now I'm going to do those inverse operations to isolate the variable. So I need to add 25 to both sides. I'm left with 2x on the left side, and negative 35 plus 25 is negative 10. Now I need, these are multiplied, 2 times x, so I need to divide by 2. And I have x equals negative 5. I can do a check one more time and go all the way back to the beginning. 8 times negative 5 minus 6 times negative 5 minus 25 equals negative 35. 8 times negative 5 is negative 40 minus 6 times negative 5 is negative 30 minus 25 equals negative 35. I have subtracting and negative, so I'm going to change this to addition. Negative 40 30 minus 25 equals negative 35. Negative 40 plus 30 is negative 10. Minus 25 equals negative 35. And now negative 10 minus 25 will be negative 35 equals negative 35. We got it. Okay, example 3 is using the distributive property to solve an equation. So remember, the distributive property is when we're multiplying by an expression that involves addition or subtraction. So we need to multiply the 2 times both the 1 and the negative 5x. So we're going to multiply that 2. So 2 times 1 is 2. And then I can say minus 2 times 5x is 10x. So 2 minus 10x plus 4 equals negative 8. Now I'm going to combine my like terms again. I have 2 constants on the left-hand side and 1 term with a variable. So let's combine the constants. I could rearrange this and say 2 plus 4 minus 10x equals negative 8. That might help to put these together. So now I have 6 minus 10x equals negative 8. I need to subtract the 6 from both sides. And I'm left with negative 10x equals negative 14. I ran out of room, so I'm going to do it up here. Negative 10x equals negative 14. I'm going to have to divide by negative 10. Negative 10 divided by negative 10 is 1, so I have x equals negative divided by negative is a positive, and 14 divided by 10 is 1.4. So I'm going to have that x equals 1.4. I kind of ran out of room to do my check here, but you go ahead and do it. Pause for a minute and put 1.4 back in for x and make sure that that works. So go ahead and pause. Okay. Example 4 is a real-life application. So here we have this table that tells us the number of miles, x, or the number of miles that we've run each day. And we don't know how far we ran on Friday. I guess that hasn't happened yet, so it's a variable, it's x. But we want to figure out how far do we need to run on Friday so that the mean, or the average number of miles that we run each day is 1.5. So we know that we find the mean by adding up all of the numbers and dividing by however many we had, how many data points. So 1, 2, 3, 4, 5. So we need to add all of this up and divide by 5, and we want it to be equal to 1.5. So that's how we're going to set up our equation. So 2 plus 0 plus 1.5 plus 0 plus x, all divided by 5, equals 1.5. So let's combine our like terms first. We can combine all of these numbers here. 2 plus 0 plus 1.5 plus 0 is 3.5. So we have 3.5 plus x, however far we go on Friday, divided by 5 equals 1.5. Now, to get the x by itself, since we've divided by 5, we're going to need to multiply by both sides by 5. I'm going to do that in another color so we can see it here. We'll multiply this side by 5 and this side by 5. So now we're left with 3.5, oops, not x, 3.5 plus x equals 1.5 times 5 would be 7.5. And now to isolate the x, we need to subtract 3.5 from both sides, and we're left with that x is 4. So we took a couple of days off from running, so on Friday we need to run 4 miles in order to get to this average of 1.5 miles per day, which seems about right. Because these two are right about on the average, and then we took a few days off, so we're going to need to run some extra on Friday. All right, I think that's it. Go ahead and try the on your own, and I'll see you soon.